Brian grew up in Sonoma County in a small town of Rohnert Park. He graduated from Sonoma State with a Bachelor's of Science in Business Economics and spent 10 years working in the financial services industry doing business development. Later in 2011, he would transition to PG&E working as a field engineer in Ukiah. That will mark him relocating to Rockland for permanent work in 2012, where he currently maintains a 13-year career with PG&E as a supervisor for service planning, where he helps extend new gas and electric services. Brian received his ham radio license in 2017, being an active scout leader for 3 sons. His early life interests in radio also include the RC, aircraft, and car hobby. Aside from ham radio, he also enjoys the outdoors, computer technology, occasionally gaming with 3 sons, knife collecting, occasionally woodworking, DIY fixer-upper, and he claims whatever else releases the inner nerdery. And with that, please welcome Brian KM6MDM to the floor.
I'm really excited to be up here because every time you guys see me, it's about boring stuff, right? So, and this has been kind of a long time coming. I built this box a year and a half ago. Did you speed it up? Yeah, no. So, it's, a lot of people have been hearing about this box. I know Ham Radio Outlet, I bought some parts from them with regards to this box, so I'm really excited to share it with everybody today. So let's get into it, all right? We're going to start with some prerequisites because it's important so you guys understand my perspective on this presentation, right? We will not be comparing battery technologies. Don made a wonderful presentation last year with regards to his battery from scratch for a lithium-ion battery, and that's still on our website. So if you guys want to dive into the real technical part of lithium technology and the assembly of it, it's a great presentation, okay? Bottom line is pick the battery and technology size that fits your budget. Now, Life PO4 batteries are getting a little pricey these days, right? They are still very expensive, but I'll tell you what, a year and a half ago, my battery cost $325 that I paid for it. Today, and even what I anticipate for Black Friday, they're just over $200. So prices are just crashing for battery technology, right? So keep an eye out for deals. There is a ton of them. Some real key brands. Mine is a Redodo battery. There's Lee Time. There's a couple of other brands out there, probably all made in the same place, right? But bottom line, pick the size and technology of battery that fits your budget. Bottom line, okay? I am not an expert in this subject matter. I am absolutely not. In fact, when I built this, I learned a lot of mistakes, and I had to correct myself quite a few times. So just know that. Be gentle. Okay. I do not claim to have done this perfectly, right? And that's really important, and we're going to get into the philosophy of use of this battery because it's going to change with every single person, okay? Bottom line is build it. You can be creative. You can have fun. It's enjoyable, right? That's why we are in this hobby. Your mileage may vary. All right. So this is number one, right? Because you can build this exactly the way you need it to function, okay? So first of all, be able to power a ham radio for field use off-grid. Number one, that's why I built it. I wanted to be able to power my radios in the field, okay? Be able to charge peripherals. I'm going to have my family with me. They're going to want to charge their cell phones, tablets, and whatever else, right? So there's plenty of USB ports on this for them to do that. Okay, be able to have backup power for short outages. Power my refrigerator, home internet, lighting. This came up about 4 weeks ago, right outside of Rockland in I believe it was just on the west side of Roseville. A car hit a pole, down power line. The whole city of Rockland was out for about 5 hours, right? I was working, right? So I fired this up with my inverter and I plugged my internet right into it, and I was right back up going for several hours until the power came on. Pretty cool stuff, right? Something I wasn't able to do before. And it is big enough that I could run my refrigerator for a few hours if I really had to, right, during a power outage. That way you're not losing your milk, right? So, have capabilities to charge with both AC and DC. I want to be able to charge it at home when I can off of the wall, or I can charge it either a DC to DC charger, or you guys will notice in this box there is a solar controller, so I can hook up a solar panel if I want to charge it. Small enough to carry and load into a vehicle for trips and field use. Keep in mind this says load into a vehicle, okay? Again, this is the philosophy of use. I am not backpacking with this thing. It's heavy, it's too big, right? And we'll wrap that up here at the end as far as some lessons learned with this box. Okay, why not buy commercial available? Well, DIY, right? So I spent a lot of time looking at commercial available units. The Jackery, Blue Eddy, Anchor now has a huge line of these portable power packs, okay? But what I found was something very distinct with them. They favor people wanting to plug in appliances, AC, right? That's what is very clear with these. If you want to plug in a USB and charge your cell phone or tablet devices, they're very complimentary of that. How about a radio? It's not going to happen, right? Let's explain why. So we are DC junkies, aren't we not? Every one of your radios that you buy is powered from DC. If I was to buy a commercially available unit, I would have to then plug in what? A power supply. So now you're taking a DC that now has an inverter inside of it, converting it to 110, and you're converting it right back down to DC to then plug in a radio. It's crazy, right? So that's another reason, again, philosophy of use. I want to power radios. I'm going to build a battery box that's specific for that use. If you notice, down here, the DC is only for charging little tablets, right? You're only getting 3 amps off of each of those USB ports, right? It's not sufficient for what we want to use it for. And if you go to the AC, even the AC side of it is only about 15 amps. And this box, this configuration, has almost the identical watt hours that the battery is that I'm going to show you guys today. So just to put it in context, a 100-watt radio HF on single sideband pulls just over 20 amps, right? That's right out of the manual of my 991A, okay? Okay, so building a box allows full control to handle loading demands. This was number one. This is why I built my own, is because I could build it to take full advantage of the full rating of that battery for whatever appliance that I'm using on the DC side. That's what's most important, okay? Ability to take advantage, we talked about that. Creating multiple fuse circuits rated for various applications. You guys will notice when you look at this, there's multiple circuits for USB peripherals. There's separate circuits for each of the Anderson power pole connectors so that you can plug in multiple radios, okay? Each one is on a separate 30 amp dedicated circuit, which is really cool. Options to adapt accessories such as an inverter to add 120 volt appliances. So now I'm adding the 120 as an additional accessory, right? I'm not going to use it most of the time, but when I do and I'm camping with my family and my wife wants to plug in a coffee pot or she wants to run a hair dryer or something like that, we have that option, okay? All right, the box. So again, my criteria, I wanted it about the size of a briefcase. And that was because as I was shopping, I did determine I'm going to target a 100 amp hour battery, okay? I wanted something sufficient enough that I could have enough capacity to use it all day long. So I wanted something briefcase sized. Benefits of a toolbox. So looking around a lot, there's the Harbor Freight boxes. You guys have seen those. They're dime a dozen. You can buy them. They're a lot cheaper. However, I got a hell of a deal on these boxes, but that's a different matter. However, There's ammo boxes. They're all over YouTube. You can watch people put batteries inside of ammo boxes and so forth. Those are all completely fine. What I found was that toolboxes were heavy-duty construction. The polymer plastic it's super strong, right? It's rigid. The handles, it's got a nice rubber grip so that when you're holding it, it's also got rubberized feet so that when you set it down flat on a table, it's not sliding around, right? All included. Really cool thing. Much better quality, fit and finish than commonly used Harbor Freight Apache cases. It's better quality, right? Look for tool sales, clearance items. It's a really big tip. This box was on clearance. They're normally $100 a piece, and I got it for $39. And I ended up buying 2 while I was at Lowe's because they had them on clearance. So look for sales, especially coming up this holiday season. Those toolboxes are going to be flying off the shelf. So just a big tip there. Wiring needed to be tidy and clean. I didn't want a mess, right? I wanted it to be nice, zip-tied, and efficient, and no rattles. Me and noises drives me nuts. So when the thing is closed down and it's being carried, or if I throw it in the back of my car, I don't want to listen to it, right? So I wanted to make sure everything was nice and tidy inside of it. The other cool benefit with some of these boxes, these toolboxes, is you can add additional accessories. There's a couple accessories where you can put like a hook so you can tie like a extension cord around it. You can also attach these little plastic containers on top that have little storage compartments and so forth. They're really kind of cool. So you kind of join the Flex ecosystem that I did on this one, but again, they're better quality, right? They give you better options. Okay, I want to talk about relays. This was a big surprise to me, right? Because I went into this project thinking, all right, well, I've got a 100 amp battery and I've got 200 amp circuits that can be isolated so that they can either be run through the inverter. So if I want to dedicate all 100 amps just to the inverter, I can do that. But I wanted to be able to isolate them by switching them on and off. So of course I go online and I'm searching for a 100 amp 12 volt switch. Well, you can't find them, right? And if you do, they're big and they're expensive and they're just ugly, right? So I'm looking around, I'm trying to do my research, and I finally opened up the world of relays. And as I learned about it, I understood how important relays are in electronics today, right? So let's talk about relays and why they're so important. So 12 volt switches to accommodate larger load are too large and too expensive for what I wanted to do, right? I needed to buy multiple of them, and I probably would have had to build a bigger case to accommodate them. They're just not practical. So relays are an important piece of circuitry because they allow an electrical device, typically incorporating an electromagnetic, which is activated by a small current or signal, into one circuit or opened to close another. What does that mean? It means that I can use a small switch to then relay a larger circuit on and off. It's fascinating, and I love it. Once I learned about it, I was like sold on it. So sure enough, I bought 2 relays that are in this box, each rated for 120 amps. And they're being run by 2 30 amp switches. So I can turn those circuits on and off with a much lower rated switch. And that's awesome because those switches are nice looking, they illuminate, they're pretty, and they're really cool. So you guys will see how that works. Relays are all over the place. They're in every single one of your cars that you drive today. Most of the buttons on your dash that operate power windows, fuel pumps, your air conditioning, those are not driven off of that switch. They're wired into a relay that then powers a much more powerful circuit in your car. So just an FYI. They're everywhere. I'm sold on relays. So Yes. To be honest with you, I don't know. I don't know that mine. I don't think mine are solid state. I think they're magnetic, mechanical. Yeah. Good question though. Okay, so inverters. When I first designed this box, I was really planning to put the inverter in the box. The reason for it was I wanted everything contained. But by doing that, I needed to maybe get a bigger box. The other part of it was heat, and it made things a lot more awkward. I also had to provide more inputs to be able to run extension cords. Inverters are kind of a pain in the butt, right? They really are. So I wanted to keep it separate. If I know that I'm just going into the field and I don't need 110, then I can leave it at home, right? I don't need it. But if I know I'm going somewhere where I'm carrying family with me and there's a possibility of using an appliance, I can bring it. It gave me an option. So you'll see how this is configured. There is a nice big input on the side rated for the inverter that I can always add and utilize, okay? Really important, know the loading demands of the appliances you plug in, right? Otherwise, these inverters, most of them that you buy on Amazon, all over the place, they're very, very small, right? They're not designed to be running large appliances. So just be careful about what you're plugging into them and know that your battery can support those demands. It's important. I recommend a power circuit isolation, especially if you're going to be running other items. So if you have a big inverter and you know you're going to be putting a lot of load on it, it's nice to be able to cut all other load off of the battery so that it's isolated. Okay, just some tips. A lot of heat, like I said, so I decided to keep it out of the box. It simplified the installation immensely, and I'm glad I did. Okay. There is, and I linked to a couple of YouTube videos that I learned a lot from, some examples. His was all inclusive, but the inverter was also about half the size. So, you get into those 400 or 500 watt inverters, there's not a lot you can use them for, right? So just some tips. Okay, so final things, and then we're gonna get into some of the build. I got some nice pictures that I can show everyone. Buy quality products. I can't stress this enough. There is a lot of garbage out there. Amazon is flooded with it, and your mileage will vary. But remember that circuits, when you start reading through those reviews, it's really clear that people start reviewing the product used for a completely different application than what you used it for, right? So that's another big thing. So read the reviews, buy good products. If you can, look for a name brand. I think it's going to save you money in the long run. That's my 2 cents. Okay. Avoid CCA cable. Do you guys know what CCA wire is? It's aluminum wire, copper-clad aluminum. So this is used very frequently in audio installations for cars. It's very cheap. It's really meant for cheap installations for audio. Buy solid copper, right? 100% copper, lead acid free, right? It's going to work forever. I bought for a really good deal. There's welder's wire online. Welding wire is always rated at really good amounts. It's good quality. The other good thing is it's very flexible, right? So if you're trying to get around tight bends, welding wire is it, especially for loads that are, you're going up into the, 4 gauge, sometimes 0 gauge and so forth. Those big wire can get really tight, right? So welding wire, just a good tip. Always check that the connectors, parts, wires used, right, no matter where you are in the system, meet or exceed the rated fuse protection on the circuit. I think we all know that, right? So otherwise you're going to be popping things all the time and you're not going to have a fun day, right? So a couple examples of that. You don't want to use 12 gauge wire on a 30 amp circuit, right? So 30 amps, you need 10 gauge wire. So make sure that you're using the size wire and also the size connectors that are rated for that given circuit. Anderson connectors. We all should know there's 3 different ratings for Anderson connectors, right? There's 15, 20, and 45, right? 30 and 45, right? So if you're running a 30 amp circuit to plug in your HF radio, you need to install the higher rated Anderson connectors, right? Be very cautious about that, right? And then follow that all the way back to the battery or where you're fused. Make sure that every piece of your circuit is rated for that same level. Just a tip, okay? Another good thing is even though you might have separate circuits going all over the place, it's always best to have an auxiliary fuse rated for that battery right at the battery. It's the same reason we put fuses right next to our batteries in our cars, right? It's that last line of protection. Even though there's a BMS in every one of these lithium-ion batteries, and those are there to help protect it too, always fuse your battery as close to it as you can, okay? Size does matter. It does. It does matter. So, and I am not going to hike with this. There's no way that I'm taking this on a soda event, right? This is meant to go in a car. It's meant to be packed on short distances, taken out to a park bench, and sat down and working for hours and hours and hours. Because this battery, I will tell you guys, you could work an HF radio for hours on this thing before it needs charged. And that doesn't even include plugging in a solar charger. But if I wanted to have something portable, if I wanted to put it in a backpack, I would have picked a much smaller battery, right? So think about, again, going back to philosophy of use. How are you going to use it? Where are you going to put it? How are you going to carry it? And use that to help dictate common sense into how you're going to build your battery, right? Big batteries are nice, but they're very heavy, right? Okay, so this is just some pictures of the box coming together. My wife thought I was absolutely insane when I ordered all these parts. This is only about half of the parts that I purchased. I ended up returning things, and I mean, it was a bit of a mess, right? But this is really where it started, right? Was getting all the parts together. And then from there, I really started to lay out my plan. You guys can see there's here's my couple of relays that I put in. That's a significant part of it. We also have bus bars, both on the negative and positive. There's a separate fuse, and I did add 2 fuses instead of just 1. I've got 1 fuse that is going to the main breaker panel. So it's between the breaker panel for all my peripherals. There's 1 fuse in between that and the battery, again, to protect it. And then you'll notice there's a second fuse that's in line with the battery and the inverter, so just as a separate protection. And what's really good about that is it's these A&L fuses. You can swap those out with whatever rating you need, right? So really cool. You'll notice there's a battery monitor. There's a Renogy battery monitor right on the front of the box. You can watch right out of from the front of it how much either power is being consumed or put into the product, right, as you're charging. It's pretty cool. This is a shunt, right? Just a nice battery shunt to be able to monitor, and that's feeding information into the front. I did get a Renogy solar controller, and that's rated for 20 amps. So this was me just, again, having all those parts, putting things together. I'm starting to think about my layout. This was the part of the project where I said, hell no, I'm not putting an inverter in there, right? It's way too big, and and if I was to put one in here, it would have been way underpowered and completely useless, right? And it would have just heated everything back up. So I ditched it. So this was the first step, right? It's layout. Here on this side, you'll see this is the peripheral side. There's there's a 1 port for a solid 12-volt plug. You'll also see that there's USB, both the A and C USB ports. What's really cool about these, and you can buy them all over Amazon or online, is they're a standard barrel size. So as technology changes and we get to a different standard with regards to USB-D, right, or whatever might come out later down the road, you can easily just unscrew it and pop your new standard configuration in there, right? Makes it really easy. You can see here these switches that I talked about earlier. I have 4 of them on the case. Every one is rated for 30 amps, and they control, 2 of them control the relays, and then the other 2 actually control the lights. So we can show that demonstration. I always envisioned having this at a campsite and being able to light up a picnic table or light up where you're working, especially if you're doing radio at night. It's kind of a nice thing to have, right? This is the front of the case where the battery monitor is, right up front. Other than that, I didn't do any other modifications. And then on this side, it's actually the input for the solar. You can see the same barrel. There's Anderson power poles inside of there. And then next to it, there's a large load Anderson connector. I think it's rated for 175 amps. But it is fused by a 100 amp circuit. That is used for the plug-in for the inverter. So you guys will see that. This is the back of the case, and I decided to make some ventilation. So I did cut some holes in the back, and I installed some fans. And then each one of these fans actually has a temperature control monitor. So it's also monitoring the temperature, so it's not running all the time. If the temperature gets over, I think, 29 Celsius or something like that. I can't remember what I put it on, but once it gets over a certain temperature, fans will start spinning up. One thing to note, and if for any of you who have built a computer, we all know that fan direction is very important, right? You don't want positive pressure and you don't want negative pressure. So the way that I built these is you can see one of them is blowing and one of them is sucking, right? So it's creating circulation through that box. And there's area right around the whole perimeter of the battery where you can feel when those fans come on, it circulates some nice fresh air through the box. Yeah. Correct. Yep. You have one that's intake and one is an exhaust. All right, so this is just about the product. You guys can see the actual finished product over here. And it's, I did make some changes from the original layout. I did move some things around and connect a few things. Going back, I want to go back a couple slides here. I can show you guys how everything is mounted. So what I did do, I forgot, sorry I didn't mention this. Right on the bottom of this box, you'll see there's actually a little 1/4 inch OSB that I had laying around in my garage. So I cut it out and I used my bandsaw to cut the curvature of the inside of the box, and I painted it black so you wouldn't see it. But I bolted that to the bottom of the box, and then all of my devices then that were going in there could easily be screwed down to it. Remember, going back to my use philosophy is I don't want any rattles, nothing moving around, nothing can get disconnected, etc. Everything is solid. It's all bolted. Okay. Here's that welding wire that I talked about. This is all 4-gauge wire. More than enough, sufficient to handle the load of the battery. All right. So from here, I want you guys to look at this. So that Renogy battery monitor, people typically use those for RVs, right? A lot of RV use or mobile home use and so forth. There is a mile-long cable that came with that thing. Well, I only needed like this much. And the lazy thing would have been for me to just shove it all in a corner, you know, and it would have been, I couldn't handle that, right? So I got my little trusty clippers and I cut that wire, and it flared out all of this insulation, and there's about 20 different wires inside of there, and it was all protected, and I was like, oh crap. So I spent literally probably 3 hours with my soldering iron, soldering every single wire back together. And then I actually took the what is the shielding and actually rewrapped that metal film. And anyway, I reconstructed a little shorty wire, and you can see it when you guys look at it. It's just one little shorty little blip wire that now goes down to that shunt. That was an intensive part of this that I didn't anticipate. So anyway, so this is the finished product. I went up to Newcastle after I built it, and I took my 2980, and in fact, it was on a Saturday during a 2-meter net, or no, it was a 2-meter contest actually that weekend, and I was hitting truckers and people all over the place who were coming back to me. So it was great. I had a little J-pole antenna up on a branch, and I'll tell you, I worked for probably 2 hours, and I did not drop 1% of battery power on 50 watts, right? In fact, I think that was pushing probably close to 80 on that 2980. So if you're running 2 meters, like a typical 50-watt type radio, you could work on this forever, literally, right? Yes.
What's the total weight of that when it's
I think it's about 50 pounds. 40, 45 pounds. Yeah, it is. I think it's right around 40, 45 pounds. So that's to my recollection.
So I have another comment. So me as in, this is KN6WQ, by the way. A lot of you guys probably know that I've been playing with some batteries too myself. And I've learned that when you run inverters, power goes really fast. Like really fast. Like, so for example, I'm running 24 volts on a 3,000 watt inverter for, the little mini split AC that I'm running. I have 8 solar panels charging the thing with 3 charge controllers. And it does a really good idea, but when you got to keep in mind though, I'm running, I think 1,800 watts, and I'm pushing almost 100 amps.
Mm-hmm.
So it like Brian was saying, the wire size is very important.
Yeah, it absolutely is. Yep. And it adds a lot of complication, too, to the whole build. But
Hey, Brian.
Yep.
Are your inverters pure sine wave or modified sine wave?
This one is a pure sine. It is a pure sine wave.
Okay.
I did a lot of researching about that. Probably for what I would use it for, not a big deal. But this one was on sale, right? So I bought the special. Questions?
Given, now that you've finished this project, I'm curious, is there anything you would do differently if you were starting over?
Yeah.
One thing I'm thinking is, clearly if it's only draining 1% over hours of use, would you have made it smaller to handle a bit less power, or do you still feel like that's a valuable feature?
Yeah.
Or what else might you adjust?
That's a great question. And honestly, today, I probably would have gone a little bit smaller, right? Just a tad smaller, because based on what I've tested so far, I could come home and charge it. I mean, I didn't need this much capacity. I'm not going to put that much load into it. So that's a great question. I think next time, I would probably think about something lighter and more portable.
Just to follow that up, Brian, ASXUS, and I, we ran a contest, and we ran 2 stations with LED lights for a 24-hour contest, and we used 135 amp hours out of a 200 amp hour battery. Mm-hmm. So yeah, 100 amp hours for a couple hours or even a weekend on 50 watts is probably way too much.
Yep.
But
don't get me wrong, there was moments where I was like Tim the Toolman Taylor on this thing, right? It's like, oh, more power, It really was. And so you have to think about that. So I was like, how much power can I get for the dollar, right? And so, I was looking at the real name brand batteries, and, for the cost of some of the really expensive ones, I was able to get a 100 amp hour battery online. I think today I'd probably go a little smaller.
Question. So you mentioned using it for the powering the fridge, which is how I started my dive into batteries and stuff. Fridge runs about 100 and some odd watts, 130 watts when it's running. The startup is about 2 kilowatts on mine for about a second and a half. So that's to be considered. For a backup battery for power outages, smaller is not good. You want big.
No, you're correct.
Would you consider getting a second thing and jumping the batteries together with a mind to making sure the voltages are equally charged?
Yeah.
But to have something for the
So I think you'd run them in. Is it you run them in series
parallel.
or parallel? Sorry. I said.
Yeah.
Can we go back to I am no expert? Yeah.
Lithium, you have to make sure they're both charged exactly the same.
Exactly,
Otherwise,
yeah.
you get a problem. But to basically augment it.
Yep. Good question.
So I just bought 2 Redodo batteries. I bought a 100 amp and a 50 amp. Out the door, it was $175 for both batteries.
Yeah, they're cheap. They are really, really cheap today. Yeah.
I just had to throw this in. After considerable effort to make an RV boondockable, if you will, a comment about your coffee pot. Most important, you do need to take that coffee pot along with you.
Right.
But do yourself a favor. Buy one that's got the stainless steel carafe that does not require the heating plate. Because what you don't realize is, it takes buku power to perk your coffee, but about every 2 or 3 minutes, boom, that heating plate goes on.
No, good point.
You're drawing about 120 amps just from that heating plate.
Yeah. I will say, too, there are a lot of DC appliances that are starting to hit the market, like DC fridges and DC, so yeah. So if they're a little more pricey, but they exist. Orion, we got a question?
Yes, just give me a quick second to find it again. Tim, KD6HOF, asks, is the thermostat for the fans mechanical or electronic?
They are electronic. Yes, they are electronic. Yeah, if you guys look, each of them has a little circuit board with a little temperature gauge on them, and then there's a little probe that's coming off of each of them that's measuring thermistor. There you go. Good question. Anything else? Any other questions? So the last page of this, I think I skipped over it inadvertently. I am providing some resources that I used. There is a link to a Amazon shopping list. So as you get ready for Black Friday especially, there is a link to a list for all of the parts that I used for this project. So you guys can click on that link. These are some really helpful YouTube videos that I got my inspiration from. So you can look at that. This guy, this Will Prowse, he talks everything about solar, battery charging. He's got a cool channel. So I leaned a lot on that guy to learn about this. And then, of course, here's the link to the box that I used. You guys can take a peek and look for sales, all right?
I have another question from Zoom. Frank, KG9M, asks, what was the investment in dollars and man hours to finish the project?
Yeah, good question. It would be less today. I'll be honest with you guys, right? It would be less today, especially the cost of the battery. I think all just soup to nuts, this thing was probably about $900 out the door, give or take. So, but I gained a lot of knowledge. I gained a lot of experience. So it was well worth it. But I was telling you guys about those commercially offered units. Those are way over $900 for the same rating. So what you can invest in building your own and the experience, it's worth it. Thank you all.
Thanks, Brian. That's awesome. Yeah, my Jackery was $1,500, so don't feel too bad.